All right, welcome to Lesson 8. This is the last lesson in our first unit for Math 0930. So I will be going through the PowerPoint with you as we always do. At the end of this video, I will also show you some other ways that you can review for our tests. So that will include the quizzes in MyLabs Plus, as well as some other materials in Blackboard, including classwork packets, which I don't know if I've mentioned to you. So I will show that at the end of this video. All right, so lesson 8 deals with properties. What I will say is this is another lesson dealing with some vocabulary words, and they might be new words for you, but my hope is that for at least some of these properties, otherwise known as maybe rules, I guess, you should recognize the patterns or the rules or the properties, even if you don't recognize the words themselves. So there's three main properties we will be learning about: the commutative property, the associative property, and the distributive property. So we'll start with the commutative property. All right, so there's a commutative property of addition, and there's a commutative property of multiplication. So here's the addition version. A plus B is equal to B plus A. Here's an example with numbers. 3 plus 2 is equal to 2 plus 3. In other words, when you add two numbers together, it does not matter which order you add them. The answer is the same regardless of order. The same thing applies for multiplication. So here's the commutative property of multiplication. A times B is equal to B times A. An example with numbers, 4 times 5 is equal to 5 times 4. Both of those will give the same answer. So let's see. Okay, so here to kind of summarize that, the commutative property, what I've written here is it changes the order. So another way to say that is if you change the order when you are adding or multiplying, the answer remains the same. Okay, that's long enough that I might want to type that out here. Okay. Oh, one more note here. This property does not hold for subtraction and division. So that is a good thing to notice here. We're going to see a lot of addition and multiplication with these properties, but not so much subtraction and division. It does make a difference when you switch the order in a division problem. 20 divided by 4 is not the same thing as 4 divided by 20. So these properties generally apply for addition and multiplication. All right, I said I was going to write out one additional note here. Oops. And I will do that. Let's see. Okay, so a couple different ways of wording what's going on here. Commutative property, A plus B equals B plus A. And then for multiplication, A times B is equal to B times A. So what I've, again, just to repeat myself, commutative or commute changes the order. Okay, so another way to say that is if you change the order in an addition problem or a multiplication problem, the answer remains the same. So that's just kind of my own words restating what this property is really saying. Okay, very good. So on the next slide, we will see some examples of how we can use these properties to rewrite some expressions. All right. And I took these pretty much from the homework. Okay, so our directions say use the commutative property, or in parentheses, I have law because your book actually does refer to this as the commutative law rather than property. It's also a rule, kind of all the same thing. Use the commutative property or law to write an equivalent expression. Equivalent means equal. So in other words, rewrite each expression in an equal way. Number one is W plus 82. This is not an equation. We're not solving for W. W plus 82 can be rewritten in a different way that is still equivalent or equal. So the commutative property, remember, it's dealing with order. So what we can do is change the order of our two numbers or variables. So W plus 82 can be rewritten as 82 plus W. that's it. I will point out here, it will be important on your homework to notice whether you're dealing with a capital letter or a lowercase letter. If you change, that's called changing the case of the letter. MyLabs Plus probably will mark it wrong, so just be careful there. Number 2 just says PQ. Capital P, capital Q. This is multiplication. So when you have two variables next to each other, they are being multiplied. So this is also the same thing as P times Q. When we rewrite this, using the commutative property or commutative law, we will switch the order. So rather than PQ, we will write QP, because those expressions are equal to each other. They are equivalent. All right, so kind of continuing the same theme here. Number 3, y times -5. So there's no time symbol. Again, there's just parentheses here. So there's a letter y, and then in parentheses, -5. Again, this is multiplication. This is the same thing as y times -5. We put the -5 in parentheses because otherwise it would look like y minus 5, which is not the same thing. When we rewrite this, we will switch the order. We will put the -5 first, and then the y. So when I've rewritten it, I did keep the -5 in parentheses next to the y. Or if a negative number is being written first and then a variable, I actually don't need parentheses around it if I don't want to. So either one is fine. I've written it as -5 in parentheses, y, or I can just write -5y without parentheses when I rewrite it. The point is I'm switching the order. Okay, number 4. B plus mx. Now this, you could really overthink this one because there's multiplication as well as addition happening. I'm going to focus on the addition. Okay, so the two terms being added are b and mx. So let's switch the order of those two terms that are being added. Instead of writing b plus mx, I will write mx plus b. So I've actually used the commutative property of addition here. I could take it a step further and use the commutative property or law of multiplication by actually switching the mx into xm. I could do that. I think that's taking it farther than we need to. And I don't want to confuse you any more than you might already be feeling confused. So let's just leave this as our answer. Okay, I just wanted to point out there's actually more than one way to rewrite this expression. Same thing for number 5. So here's number 5, 3 minus 2x. Okay, we need to be careful here because subtraction was not part of this property or law. There was a commutative property of addition and then multiplication. So what are we supposed to do with subtraction? What I'm going to do is I'm going to remember that any subtraction can be rewritten as addition. So what I'm doing first is rewriting this problem. Instead of 3 minus 2x, I'm writing 3 plus -2x. Those are equivalent. We learned that when we were learning about subtraction, right? Anytime you subtract, you're really adding the opposite. So instead of subtracting 2x, I'm adding -2x. Now I can switch the order. So now I can go from 3 plus -2x, and I can write -2x plus 3. And that can be my final answer where I've switched the order. I've used the commutative property or the commutative law of addition, even though the problem started out with subtraction. So the common theme for all 5 of these problems is we use the commutative property or commutative law to simply switch the order of our two different numbers or 2 different variables or 2 different terms. A term, I guess I should define that, sorry. A term is, how do I define it? You know it when you see it. So mx is a term, 2x is a term. A term can be a number and a variable multiplied together. I'll just leave it at that for now. We talk about that more in our next algebra class. So once again, the main idea here is we've switched the order. Whether it's an addition problem or a multiplication problem, we've taken our 2 numbers or terms or variables and we have switched the order. All right, next slide. So we're going to see our next property now. The next property is called the associative property. the way I remember this one is I think about who do I associate with, or who are my associates? Those are people in my group. That's a very vague statement, but that's how I remember this one. This one has to do with grouping. So we'll start to see some grouping symbols, some parentheses. Let me make sure everything here is all set. Okay, so here are the properties related to the associative property. So there's one for addition and there's one for multiplication. Okay, so for addition, in parentheses, a plus b, close the parentheses, plus c equals a plus, and then in parentheses, b plus c. So if I just say it out loud, a plus b plus c equals a plus b plus c. It's just a switch in terms of where the parentheses are. The parentheses can be around a plus b, or the parentheses can be around b plus c. I can group the numbers differently, okay? So in this property is dealing with switching up the grouping. Okay, so when we are adding numbers, we can group them differently and still get the same answer. So here's our example for addition. So in parentheses, 2 plus 4, close parentheses, plus 5. Let's simplify that. 2 plus 4 is 6. 6 plus 5 is 11. Okay. Now, on the other side of the equal sign, we also have 2 plus 4 plus 5, but on the other side, it goes like this. 2 plus, and then parentheses, 4 plus 5, close parentheses. So if I simplify the parentheses first, 4 plus 5 is 9. So on the other side of the equal sign, I'm writing 2 plus 9, but look, it's also 11. So both sides are, in fact, equal to each other. So both sides had 2 plus 4 plus 5. We just changed how we grouped the numbers together. So the intermediate step, the 6 plus 5 or the 2 plus 9, that was different, but the final answer was still the same. That's what this property is saying. If you switch up the grouping, your expression and your answer are still equivalent. They're still equal. Then we have a similar version of this for multiplication. A times B times C equals A times B times C. The difference is on the left side, we have A times B in parentheses. And then on the right side, we have B times C in parentheses. So again, A, B, C, it's just the parentheses are kind of shifting in terms of where they are. So our number example, we have 3 times 5 times 2. The 3 times 5 is in parentheses. So 3 times 5 is 15. 15 times 2 is 30. That's the left side. On the other side of the equal sign, 3 times 5 times 2, it's just that this time 5 times 2 is in parentheses. So we'll group those and we'll simplify that first. So 3 times parentheses 5 times 2. 5 times 2 is 10. 3 times 10 is 30. So these number examples are just sort of illustrating the property working. They're not proof. You can't prove something with one example, but it's showing that it does work in this case. And we're not going to talk about in-depth proof in this class. Somebody's already done that. We just get to take advantage of the fact that mathematicians have agreed that these rules always work. So the associative property works for addition. You can change your grouping, how you group the numbers together when you're adding. And it also works for multiplication. You can rearrange the grouping. You can change the grouping, you can change where the parentheses are, and your answer will still remain the same. Once again, that does not necessarily hold true for subtraction or division. So those are not listed here. All right, good. So once again, let's move on and take a look at some examples. So you can see what I just said. This property does not hold for subtraction and division. If you change the parentheses in a subtraction or division problem, that could definitely change your answer. Okay, here we go. So here's our set of examples. Use the associative property or law to write an equivalent expression. Okay, number 1, 2 plus parentheses 3 plus 4. So let's rewrite this. I will still write 2 plus 3 plus 4. It's just that instead of putting the parentheses around the 3 plus 4, I will put them around the 2 plus 3 instead. The directions did not say to simplify or find the answer. I know you can all add 2 plus 3 plus 4. The answer would be 9, but that's not the answer we're looking for. We're looking for the rewriting process. So you can see that when you rewrite and you change the parentheses, those answers, those expressions are once again equivalent or equal to each other. Number 2, 4 parentheses 5x. This is a multiplication problem. I will rewrite 4, 5, and x, but I want to rearrange where my parentheses are. Instead of being around 5x, I'm going to put it around the 4 and the 5. Now what's missing here, if you can see this, it looks like I've written 45 with a space in between. It's not 45. What I need is, I do need a multiplication symbol here. A little dot will be fine. So what I've rewritten, instead of 4 parentheses 5x, close parentheses, what I've rewritten is parentheses 4 times 5, close parentheses, then x. This is a little awkward. I know it's a little bit strange. The final answer here would be 20x. Okay, we're going to see that in our next unit when we get into working with variables some more. Without even realizing the property that you're using, you're going to automatically just know to multiply 4 times 5 and get 20. But this is the property or law that allows us to do that. Okay, so once again, I've rewritten the problem. It almost feels like you're copying it down exactly. It's just that you've switched where the parentheses are. Okay, number 3, in parentheses, v plus 2, close parentheses, plus w. When I rewrite this, I will rewrite v plus 2 plus w. Instead of keeping the parentheses around v plus 2, I'm just going to shift them over and put them around the 2 plus w. So my final answer is v plus parentheses 2 plus w, close parentheses. Those expressions are equal. Number 4 is similar, 8 times y times z. It started out with the 8 times y being in parentheses. When I rewrite this, 8 times y times z, I will instead put the parentheses around the y times z. So my final answer is 8 times parentheses y times z. So with the associative property, think about your associates are in your group. Who do you associate with? It's all about grouping. Okay, so associative property deals with changing the grouping symbols, which is different from the commutative property, which deals with changing order. So with addition and multiplication, order can be changed and grouping can be changed, and you can still end up with the same answer. All right, we have a couple of tricky questions here. These are multiple choice questions. It says, use the commutative and associative laws to find 3 equivalent expressions. So number 1 starts out in parentheses, in parentheses, y plus x, close parentheses, plus 3. Now we have some choices below, and the question is, which equivalent expression does not use both laws? Both laws meaning the commutative to switch order, and then the associatives to switch grouping. So all of these expressions are equivalent, but there's only one that doesn't use both properties. So we have to get a little bit detail oriented right here. So for each choice, I'm going to check, compared with the first expression, has anything changed in terms of the order? And has anything changed in terms of grouping? So again, the original expression was in parentheses, y plus x, close parentheses, plus 3. Choice A, x plus parentheses, y plus 3. Okay, x is first now, so we've definitely changed the order because y was first before. So order is good. Order has been changed. Grouping has also been changed. In the original expression, it was y plus x grouped together. Now it's y plus 3. So order and grouping have both changed. So that one's fine. Sorry, my handwriting is so messy there. Sometimes I forget other people are reading this along with me. I was just kind of making a checklist for myself that we were changing order and grouping. So I'm just going to do 2 check marks to say that we checked both. So that will not be the choice that we choose. Next option, choice B, in parentheses, y plus 3, close parentheses, plus x. Okay, the order has been changed. Instead of y plus x, it's y plus 3, so the x and the 3 have switched order. And the grouping has also changed. Instead of y plus x in parentheses, now it's y plus 3 in parentheses. So once again, we found one that does change both order and grouping. Choice C, y plus parentheses x plus 3. The order here is the same as the original problem. The original problem had y plus x plus 3, and so does this one. So I think this is our choice we would select because it has not used both laws. I'm going to say it does not use the commutative, I'm abbreviating, law because we didn't switch the order. So that would be the choice we would choose. They did switch grouping, okay? So instead of y plus x, it's x plus 3 being grouped together, but the order is still the same. Now, just to be sure, choice D, y plus parentheses 3 plus x, the order has been changed in that one and the grouping has as well. So choice C would be our answer there. Okay, tricky stuff, I know. Number 2, same question, same directions, I mean. So this one is multiplication, 6 times parentheses x times y. Which equivalent expression does not use both laws? So once again, we're looking for order and grouping both being changed each time. Choice A, x times parentheses 6 times y. You can see the order is different. X is first instead of 6, so order is different, and grouping is different. Instead of xy in parentheses, it's 6 times y in parentheses. So that's not the choice we'll choose because both laws have been used there. Choice B, 6 times y times x. The 6 times y is in parentheses. X and y have switched order and the grouping has changed. Instead of xy together, it's 6y together. So this is another one that has used both laws. Choice C, x times 6 in parentheses times y. Same story. Order has changed and grouping has changed. X times 6 is grouped together instead of x times y. So I guess it better be choice D. Let's find out. In parentheses, x times y times 6. So the order changed. Instead of 6, x, y, now it's x, y, 6. So the order changed, but this time it was grouping did not change because the x times y are still together. So I'm writing grouping did not change. So the property we didn't use, it does not use the associative property this time because we didn't change which variables were grouped together. It was still x, y both times. So that would be our choice that we would choose. So I know those are kind of weird little logic questions dealing with properties. Again, the two properties we've seen so far deal with order being switched, that's the commutative property, and then associative law that deals with grouping. All right. So here's our last property. This one is called the distributive property. We're going to use this one a lot coming up. All right, so here's the official definition or algebra example. A parentheses B plus C is equal to AB plus AC. I like to illustrate this property using arrows. So what I'm doing is I'm taking the A on the outside of parentheses and I'm drawing an arrow touching the B. Then I'm going to draw another arrow from A to C. So this is showing that I'm going to be multiplying each number or variable inside the parentheses by what's outside the parentheses. So again, A parentheses B plus C, that's equal to AB plus AC. So you can see how this one kind of combines multiplication with addition in this example. It can also work with subtraction. So here's an example with numbers, 2 parentheses 3 plus 4. If I distribute, I can do 2 times 3 plus 2 times 4, and that's what's being worked out over here on the right side. 2 times 3 is 6, 2 times 4 is 8, and then we add those together, 6 plus 8 is 14. On the left side, we've just used order of operations to simplify. 2 parentheses 3 plus 4, we've just added 3 plus 4 is 7, and then 2 times 7 is 14. This is yet again another example showing one example of the property actually being true. But we're not really going to use it so much with just numbers like this. It comes into play when we are seeing expressions with variables, so more letters coming up. All right, let's practice using this property. All right, so here's our instructions. Multiply by using the distributive property. So number 1, in parentheses, 2, or sorry, let me be clear about that. The 2 is not in parentheses. So 2, then start the parentheses, x plus 5. So I'm going to draw my little arrows here. 2, parentheses, x plus 5. So I'm going to multiply 2 times x plus 2 times 5. Then I will simplify. 2 times x, we can just write 2x plus 2 times 5 is 10. That is my answer. Okay, so my simplified answer does not have parentheses anymore. Each of the numbers or terms inside the parentheses has been multiplied by 2. So that's where we got 2x, and then 2 times 5 is 10. So my final answer is 2x plus 10. Next problem, number 2. -3, parentheses, 2y minus 8w. Each term in the parentheses gets multiplied by -3. So we're being careful with signs. So I'm going to write -3 times 2y. This time, instead of writing plus, I can write minus because of that minus sign, and then -3 times 8w. It's a little awkward with all those different signs. So again, -3 times 8y minus -3 times 8w. Either way, those two signs are about to cancel out, okay? That minus and that negative, treat it like negative times negative. This will turn into a positive when we simplify that second term. So let's write our answer. -3 times 2y is -6y. When we subtract our negative, this is going to turn into plus 24w. So -6y plus 24w. Another way to see what just happened is we were subtracting a negative 24w, but you know when you subtract a negative, it turns into a plus. It turns into addition. So our final answer there is -6y plus 24w. So please notice that when we distribute a negative, our signs change. Okay, so that's an important little note there. Okay, so our signs are changing from what they were to begin with. Okay, I'm trying to highlight and talk at the same time, sorry. So the positive 2y became -6y, and then the -8w became positive 24w. Alrighty, a couple more, 3 more to be exact. Number 3, 5x, parentheses, y minus w minus z. So the 5x gets multiplied by each of those terms. There's 3 of them. 5x times y is just 5xy minus 5x times w is just 5xw minus 5x times z is 5xz. So that one might have looked like a harder problem, but I found it to be easier because there was not any extra calculation to do. You're kind of just writing the letters next to each other. So each of the terms got multiplied by 5x. So again, the final answer is 5xy minus 5xw minus 5xz. All right, number 4, this time we're distributing 1/3 z. So it's 1/3 z, parentheses, r plus p. So the 1/3 z gets distributed. Again, I don't think it's as hard as it looks. 1/3 z times r is just 1/3 zr. See, when there's so many variables, we don't know what they are, so there's almost less work for us to do. You're kind of just writing it out. So 1/3 zr plus 1/3 zp. And that's it. See, not so bad. And then, excuse me, number 5, this comes from an actual geometry formula, 2 pi r parentheses h plus 1. So we're going to distribute 2 pi r and multiply it by h, and then multiply it by 1. So 2 pi r times h, and then 2 pi r times 1. Well, 2 pi r times h is just 2 pi rh plus 2 pi r times 1 is 2 pi r. Because anything times 1 is just still the same. Okay, really what's going on there is 2 times 1 is still 2 for that first number part here. So I know some of those seemed a little more complicated because there's a pi in there and there's a fraction, but I hope that you also see it didn't necessarily make the problem any longer. Okay, so I took those problems straight from the homework, so you should recognize those when you get to homework number 8. All right, I'm going to switch gears now. That's the end of our notes examples here. I'd like to show you some other things you can do to get more practice with this lesson, of course, beyond the homework. So the first thing I'm going to do is actually take you to Blackboard. So I'm going to switch the screen here. So here I am at my Way page. By now you should know where Blackboard is if you're watching this video, but here's how I get there. I just click on the B symbol for Blackboard and then get to our course. Under My Courses. All right, so I'd like to show you some things that are available in Blackboard, specifically the classwork packets. Okay, so you already know about videos, PowerPoint notes, etc. But let's go to the classwork packets. So these are what I would normally hand out during class if we were physically together in a classroom. So you'd be getting a lot more paper from me in other circumstances. For each lesson, there's a whole packet of extra questions. You can see I've titled it classwork. We would normally use these to work on during class as extra practice. This is not homework. These are not required. I've used them for warm-ups during class, etc. So I'd like to show you that there's one for each lesson. Sometimes they're grouped together. Anything that says key, that's a fully worked out answer key. Okay, so let me show you for lesson 8 that we just went over. This is classwork number 8 on properties. So I'm clicking here. It opens up a PDF file right here in the screen. So you can see classwork number 8. And here's just some more problems similar to what we just worked on. Okay, so write an equivalent expression, use a commutative law. So this is the one where you're changing the order. And then the second set of questions, use an associative law to find an equivalent expression. That's where you're changing the grouping, the parentheses. Okay, so there's a whole page full of just little extra practice questions. Here's some of those little trickier multiple choice, determine which expression is not equivalent. So we went over those. And then finally, the distributive property. So I gave you 5 examples, but there's a lot more than that here that you might choose to work on. Okay, so I just wanted you to know that this was here for you, and then there is an answer key to go along with it. So inevitably, by only showing you 5 problems, I might have missed something, and there might be more that you need help with. So what I'm noticing right at this moment is I see some fractions where you do actually need to do a little more work. So just really quick here, number 31, 1/5, parentheses, 15x minus 10. When I distribute that 1/5, it's going to look like this. 1/5 times 15x minus 1/5 times 10. Let's actually simplify that. That will not be an acceptable final answer. I need to actually multiply each of these numbers by 1/5. So I'm going to put the 15 over 1 and the 10 over 1. 1/5 times 15, if I just reduce the 15 and the 5 by 5, that turns into just 3 over 1. This first expression, this first term, I mean, 1/5 times 15x, it just turns into 3x. It would be 3x over 1, but it's really just 3x. Then minus. Similarly over here, 1/5 times 10, if I reduce the 5 and the 10 by 5, that just becomes 2. So this answer will be 3x minus 2. That was number 31 in the classwork, the optional classwork. And you can see I can check my answer by scrolling down and checking. There's number 31 right here. 3x minus 2 was the answer. All right, so those problems are there for you. I have the answer key at the end, as you saw, but for a couple of lessons, I did make a fully worked out answer key. So I'm going back to the classwork packets right now. And I would like you to notice for lesson 1, there's a key. For lesson 6 and 7, there's a key. And then for lesson 8 as well. So I'll show you what the key looks like. It's essentially, it's photos of my own handwriting. So this is the actual printed out packet, and I've written out all the answers and written little notes on there. So maybe for a fraction question, there might be a little bit, yeah, see, here's number 31, a little bit more work shown. That might be a little bit better help for you. So just take advantage of that as some extra practice. Again, this is totally optional. I'm guessing even though we're here in lesson 8, some of you might still be struggling with fractions, which, as you will remember, that was lesson 1. So if you're still struggling there, classwork 1 is full of extra practice. And then here's the key. I'll just click on the key here with together. So you can see the steps fully worked out. So classwork 1 on fractions. This is a good thing to use for review. All right. And one other additional review resource under videos. If you go all the way to the bottom here, lesson 6, lesson 7, by the time you're watching this, you would have seen lesson 8. And I've added these 4 extra videos. These were made by a student named Anu, who she is a student at Metro. She also works as a tutor, as a math tutor. She's been a classroom assistant, and she has used Zoom, as I'm doing right now, to make some videos for us. So these are just extra examples going over operations with fractions. So I'll just click on one just to show you a little idea of what this looks like. I'll start with addition here. Okay, so it doesn't take you to a link like mine do. You can just watch it right here in Blackboard.
Okay, everyone. Thanks for tuning in to the next video. And as you can see, we'll be talking about addition of fractions.
Okay, I'm pausing here. So you can see she's put a title, and she's going to talk you through some examples. The examples she's doing, for the most part, actually come from the classwork packet. Not all of them, but I gave that to her as a resource of problems. So you can see she does a nice job writing out the problems. She takes it nice and slow. I think she's really clear. So this is another thing you can take a look at for some extra practice with fractions. So again, there's a video for each operation with fractions. She does addition for this first one. You can see it's 37 minutes. Feel free to skip ahead. Sometimes it's nice to just see somebody else working things out. She gets into different denominators, etc. So she made a video for addition, subtraction, multiplication, and division. All right, good. So again, that was in videos, and those are all the way down here. There's a video for each operation with fractions, which might be a great resource. All right, the other thing I wanted to remind you about in terms of things you can do to review now that we're at the end of our first unit is in Blackboard, we do have quizzes. I'm going to pause my recording briefly so I can get that open for you more quickly, and I want to make a little bit of a few comments on the quizzes that are available. Oh, and the review test as well. Okay, just pausing for a moment. Okay, welcome back. So, or I guess I'm welcoming myself back from being paused. So here we are in MyLabs Plus. Here's our assignments. We're looking at homework here. I wanted to remind you about quizzes. Quizzes are optional. They go in order with the assignments. So wherever a quiz shows up, it will cover the assignments that come before it. So quiz 1 and quiz 2 are optional review opportunities. It will give you a grade, but the grade does not affect your standing in the class for good or for bad. It's just there for practice for you. Okay, so here's quiz 1. It covers lessons 1 through 4. And then quiz 2 covers lessons 5 through 8, multiplying and dividing, exponents, order of operations, and properties that we were just doing. Also, there is a review test. This is listed under the test category, but once again, it's optional. and the grade does not affect your overall grade in the class for better or for worse. And you can see there's infinite tries that you can do. So that test is a longer version of what our actual test will look like. So let me show you a little bit for each of those. Here's the quiz. This is quiz 2. All right. There it is. So you can see quizzes are timed. Most students don't need the full amount of time, but if you need more, you can ask. But I've noticed most students finish it in more like 20 or 30 minutes rather than 75 minutes. Let's click Start Tests. So again, this is a quiz. This is optional, but it's good practice. Okay, so especially if you've really gotten a little bit too comfortable clicking View Example every time when you're doing the homework, this kind of forces you into that test environment where there's a timer going and the help buttons aren't as readily available. Okay, things are just a little bit slow right now. Okay, I'm gonna pause for a minute here and just check on something. Oh, is it okay now? Yeah, I'll pause for a second. Okay, I'm back again. So I just had to open it again. I don't know why. It happens. So here's quiz 2. There's 15 questions. Again, this covers lessons 5 through 8. I think I'll just take us near the end of the quiz because it does cover what we were just talking about in terms of properties. So I'm just skipping ahead to question 11. Okay, here's an order of operations question. We did one almost exactly like this in lesson 7. Okay, here we go. So here's number 12 in the quiz. Use a commutative law to find an expression equivalent to z plus 63. Okay, commutative law, that's the one about switching order and maintaining an equivalent expression. So if I just switch the order, instead of z plus 63, I'll write 63 plus z. And you can see on a quiz, I can't check my answer here. There's no question help available. So I would do the homework first before you come and take a quiz. But this is, again, good practice. That's number 12. Here's number 13, associative law, u plus parentheses v plus 5. So I would write, let's see, I still want to write u plus v plus 5, but instead of the parentheses around the v plus 5, I want them shifted over to be around the u plus v. So I will type parentheses u plus v, oops, and then plus 5. So I did u plus v in parentheses plus 5. Number 14, okay, here we are distributing. So multiply 17 parentheses z plus 1. So I'm going to distribute the 17 times z plus 17 times 1. That's really just 17z plus 17. So that's what I will type in my answer there. 17z plus 17. All right, and then number 15, this time I'm distributing -8. So it's -8, and then in parentheses, 2a plus 9b. So -8 times 2a plus -8 times 9b. Okay, -8 times 2a, that's -16a. Now I wrote a plus, but this is about to be a negative number, so plus -72b. Or I can just write -16a minus 72b. That would be my answer. Now, I do want to type in a wrong answer on purpose right now, just so you can see what that looks like when I'm done with my quiz. So instead of doing it correctly, I'm going to do it wrong on purpose. All right, so -16a, it should be minus, but I'm going to just write plus 72b. Okay, I'm going to submit my quiz. I didn't do it all, but that's okay. I'm going to just submit it, and I'll be okay with getting a low score here. Okay, so you can see my score, 20%. I got 3 out of 15 points. All these little X's in parentheses are questions I did not answer. The green check marks are the ones I got right. Here's number 15 with the big red X. I got that one wrong. So let's click on that. It's going to hopefully let me review this. Maybe. Maybe it's already open. There it is. Okay, so here's number 15. You can see the red X, I got it wrong. In the light blue space is the correct answer. That is not what I answered. So if I click here with my mouse, here's what I answered. So now I can see, oh shoot, I did the wrong sign. I should have put a minus sign, but instead I put a plus sign in front of the 72B. I can click and get answer feedback. Which may or may not feel very helpful, but it's just reminding you about the distributive law. Now you have question help available, so you can view the example, ask my instructor. So after taking a quiz, definitely review it, and then you can get extra help and send me an email if you need to. All right, good. So I'll close that for now. Okay, and I'm going to share one more time. The last thing I will show you is the review test, just to give you a little preview of what that looks like. Review test 1. Okay. Okay, so we're about to start this test. Again, this is a review test. This is just for practice. You can see I have unlimited attempts. There's 40 questions. That is longer than our test will be. I don't have an exact number for you at the moment, but usually it's closer to maybe 25 questions. But think about all the different questions we've done in this class. They're not all the same, right? Some of them are very short. Some of them are a little bit longer. Okay, so taking this test is similar to taking the quiz. It looks like there's no time limit on this review test, so you can take as long as you want. So you can also close out of it and come back to it, unlike a real test where you cannot do that. And it looks like for this review test, the help options are left in. I forgot about that. That's for your own good. Okay, so take advantage. The thing you can't do is you can't check your answer. So here's number 1, simplify 2/8. I can view the example to see how to simplify a fraction, but when I do simplify it, I won't be able to check my answer. I can't tell if I got it right or not until I submit the entire test. Okay, so this generally goes in order from lesson 1 through 8. And again, it's longer than an actual test would be. Okay, good. All right, I know I'm showing you a lot. The last thing I want to remind you of is showing your work for a test. This should be similar to how you've been showing your work for the weekly written homework. And there's a folder in Blackboard where you will be able to submit it. So here we are back in Blackboard. You've been submitting homework in this Submit Weekly Written Homework folder. You've only done a couple of those at this point, but I want you to know for a test, you'll click here for test work submission. And then the assignment just says submit test 1 work here. Okay, and that's where you would upload probably a photo or a PDF, whatever you've been doing to submit your weekly written homework. If that's been working for you, do the same thing for your test. It's probably going to be multiple pages, so feel free to submit multiple photos, or if you're able to combine them, that's fine. This is how I will be grading your test. Okay, so when you submit your actual test in MyLabs Plus, you will not see a grade. That will be hidden from you. I need to see your work in order to actually grade it. Okay, good. So I know that was a lot of information at the end of our lesson 8 video. Please let me know if you have any questions on the material itself and then on any of the procedures that we've been using for this class. All right. Thanks very much for sticking with me, and I will see everybody soon. Thank you.